And here we are again. So this is the last video in Unit 1, and it's about one of the key fundamental topics for your AS course, and that is moles. So what are we going to go through with this video? You should be able to give a definition of what a mole is and be able to use this definition in simple calculations. Okay, being able to find the amount of atoms or molecules or ions in a given amount of a substance. Now, before we move on to the mole, I just want to go through a couple of definitions which you should have come across during your GCSE, although perhaps not in this much detail. Now, the first one is the relative atomic mass. Now, I'm going through these two definitions because I'm going to be using them when explaining what a mole is. So first of all, relative atomic mass. Now, definition is given here. This is one of the key terms highlighted in your book. Therefore, I want you to be adding it to your glossary. Okay? This is also one of the key definitions which you may have to give word for word in an exam answer. Okay, so you need to learn these. So the relative atomic mass of an element is the weighted average mass of the element. In other words, the average of all of the isotopes of that element. And remember, in terms of relative atomic mass, we are comparing it to 1/12 the mass of a carbon-12 atom. This is just a technical definition, okay? But remember, you do need to know these off by heart, and I will be giving you regular definition quizzes in class, so make sure you learn them. You don't just put them in your glossary and leave it until May, okay? The second definition, which is linked to the first, is just the relative molecular mass. Now again, here is the definition that you have to learn, okay? But it's basically just all of the relative atomic masses of the atoms in a molecule added together. You should have done this during your GCSE. Okay. Right, so now that we have these two definitions, we can go on to what an actual mole is. So a mole. Now a mole is not a cute furry little creature, not in terms of chemistry anyway, but we will keep this guy here. This is our mascot for this lesson, Avogadro. Okay, so first of all, let's just get the definition out of the way, another one you need to learn. 1 mole is the amount of substance containing the Avogadro number of atoms, molecules, or groups of ions. So you can see by definition that is linked to something called the Avogadro constant, or the Avogadro number. So let's just go through a few examples, because this is the best way to learn what a mole actually is. Right, let's just write down a couple of headings to start with. So we're going to look at a few examples. Start with the substance, go on to the relative atomic mass or the relative molecular mass. Then we're going to have a look at number of particles of the substance. Then have a look at the mass. And then finally, the number of moles. Okay, so let's just start with the simplest example. Let's have a look at hydrogen. So, hydrogen atoms. Put atoms in brackets. Okay, so, simplest one, relative atomic mass of hydrogen is just 1. Now, relative atomic mass has no units. And as we know, that is because it's just compared to 1/12 the mass of a carbon atom. It's not a quantity we can use. Okay, so if we need to measure out certain amounts of hydrogen for an experiment, the relative atomic mass is not particularly of any use. We need it in actual physical amounts that we can measure for our experiment. Now, as you know, the common unit of mass is grams. So, how can we get 1 gram of hydrogen? Now, Avogadro was a very clever guy, and he worked out how many particles, in this case of hydrogen, would be needed to have 1 gram of hydrogen. Now, this number is 6.022 times 10 to the 23. And this is what we call Avogadro's constant. Okay. So if you have 6.022 times 10 to the 23 atoms of hydrogen, you will have 1 gram of hydrogen. And this is what we say is 1 mole. Okay, so 1 mole of a substance is the relative atomic mass, or the relative molecular mass, of that substance in grams. Okay, let's have a look at another element. Say sodium again. Let's have it as atoms. So, relative atomic mass of sodium is 23. So, if we have 1 mole of sodium, that means we will have 23 grams of sodium. Okay, and that is because we have 6.022 times 10 to the 23 atoms of sodium. Now, because the relative atomic masses are relative to each other, 1 atom of sodium is 23 times heavier than 1 atom of hydrogen. Therefore, if you have the same number of each of these, the 1 mole of sodium will be 23 times greater in mass. And you can see that here. 1 gram of hydrogen is 1 mole, whereas 1 mole of sodium is 23 grams. Does that make sense? It's all about the sort of ratio of masses between the different elements. Let's expand the definition slightly. Let's go to a hydrogen molecule. Okay, so we now have a molecule, so we need to use the relative molecular mass, which is obviously 2. Now, if you have 6.022 times 10 to the 23 molecules of hydrogen, you'll have 1 mole of molecules, and therefore the mass will be 2 grams. It is the relative molecular mass in grams. Okay, so moles are to do with the number of particles of a substance. Okay, and if you go back to your definition, it is linked to the Avogadro number of atoms or molecules of a substance. Okay, so in this case, because we're talking about molecules, 1 mole of hydrogen molecules is 2 grams, whereas 1 mole of hydrogen atoms is 1 gram. Mole is just an amount. Okay, so just be careful with the wording, atoms, molecules. Okay, so let's just stay with these examples. Let's go back to sodium atoms. Okay, so relative atomic mass, 23. Let's say this time we want 2 moles of this substance. So, how many atoms would you actually have? So you take 6.022 times 10 to 23, and you just times it by 2. You have the Avogadro number of atoms in 1 mole, so if you have 2 moles, you just multiply it by 2, okay? Which just comes out as 1.2044 times 10 to 24. And that is how many atoms of sodium we would have in 2 moles. Now the mass of this would be 46. As we know, 1 mole has a mass of 23, 2 moles, mass of 46. Okay, so hopefully you're now starting to appreciate the link between what mole is, Avogadro's constant, the mass of the substance. Now let's just go through an example which has come up in a previous past paper. So, what is the total number of atoms in 1.8 grams of water? Obviously H2O. Now notice the word atoms, I've put it in bold. Okay. Now, what are the different steps? So, first step. Okay. What is the MR of water? So, oxygen, relative atomic mass is 16. Hydrogen is 1. So, 16 plus 1 plus 1 is 18. So, you do not need a calculator to realize how many moles of water we have, because 1 mole would be equal to 18 grams. So the fact that we have 1.8 grams means we have 0.1 moles. Okay, so we have 0.1 moles of water. So the next step, once you have the number of moles of a substance, is to work out how many molecules we have. Molecules, or shall I say, number of molecules. 1 mole would be 6.022 times 10 to the 23 would be 1 mole, but we only have 0.1 moles, so times that by 0.1. Now this comes out at 6.022 times 10 to the 22. Okay, we've just divided by 10. So that would be the number of molecules, but in the question it asks for number of atoms. Now, how many atoms are there per molecule? So in this instance we have H2O, so there are 3 atoms in 1 molecule of water. So if we have 6.022 times 10 to 22 molecules, all we do is times that by 3 to get the answer. So if you pop that into your calculator, it comes out at 1.8066 times by 10 to the 23 atoms. Okay, so up here we worked out the number of molecules, but the question asked for atoms. So be careful you don't miss out this last step. Okay, so hopefully you can now give a definition for what a mole actually is, and you should now have some idea about how to use Avogadro's constant to work out the number of atoms or molecules or even ions of a given amount of substance. If you're unsure about any of these, please look through the video again and make sure you finish your notes for class.